Shivanaresh is my classmate from engineering. So we were all from the same batch of engineering. And that's how I got in touch with all of you. And thank you, Shiva, again for this opportunity. So from a career perspective, so I'll go from, like I said, I graduated in chemical engineering with a BTech degree in 2002, which all of you guys will also be getting in some years down the line. I don't know, based on where you are in the degree. After that, I didn't know how to pursue. Frankly, neither did my parents or neither did I have a bunch of people to coach me. Okay, what is your next step? How should you proceed next? But then luckily some good friends, so they suggested, let us try to do this sort of writing a GRE GMAT, which most of you know right now. So try to do that, and then got some funding, and so I was qualified to get a scholarship back then, and then I pursued my master's in chemical engineering at that point. So I graduated it in year 2005. Post that, I worked for a couple of years. I'll talk about that in my work experience. But eventually I realized if you want to do something more, if you want to learn something more about being a being more profound in one area, the only way you can do it is pursue a PhD. That's the only way you can establish your credibility and say that, okay, this is where I want to learn more and I want to give back to the society as well as to the particular program. I want to give it back. So that's the only way I can contribute, according to me, at least, was to do a PhD. That is where I slightly shifted gears. Like you can see, I moved from chemical engineering to biomedical engineering. If you look at it, it's not just biomedical, it is more on the applied biomedical engineering. So clearly, like the name says, you learn something, you need to know how to adapt and how to apply it. That's what we have to do. So that is more what I have done in my PhD. I didn't talk much about what I have done in this presentation, but if anybody has questions, please feel free to email me and I can reply back to those questions. So then coming to the work experience, right after my master's, I worked as a research scholar. It's called a section of cardiovascular imaging. It's a hospital. It's a huge hospital establishment in the Cleveland, Ohio. So there I worked as a research scholar in cardiovascular. What is cardiovascular? It's more about your heart. That is where my area of expertise is. So about how do you image your heart? A lot of people must have heard about heart attack, etc., right? So how do you help those patients? That's all we do in the cardiovascular imaging. Next, after that, I've done some more biomedical engineering work more on the technology side, developing pulse sequences means, what does that mean? So if I want to make some images look like a particular way from the patient, how do I help to do that? So that is more what I have done in the pulse sequence designing. That I worked for a couple of years, and then I went back to pursue my PhD. And post PhD, I worked again in the cardiovascular imaging lab as a visiting scientist. Like after that, there were two big chunks of job. I moved back to India. My first was as a senior systems engineer in CT systems. There, what we have developed is something called a CT scanner. So I'm pretty sure most of you know about it. But there's one particular scanner called ACT-CT. What is so special about it? It's a completely low end in the country for the country innovation. So this is even before the Made in India came, I think GE got smart about it. They thought that, okay, let us make something in the country for the country. So that entire CT scanner was designed, manufactured, and assembled and sent out all across in India. So I'm very proud to be a part of that project, and I was one of the lead senior systems designers for that from Bangalore. We worked on it. And right now that CT scanner, the beauty of that is it goes on catering to all these small hospital sites. I don't know if you've heard of them. There's a hospital site called Yavatmal in very rural area in Maharashtra. And there's one Begusarai in Bihar. I mean, all these places I visited. You should see the life of the people there. Extreme lack of resources, lack of poverty. Lack of resources and lot of poverty. But all these CT scanners that we've deployed in those multiple places, they will help in giving them a better health care. So that the whole point is, how are we using our education and all to improve our country's infrastructure, or our country, how are we making our country a better country for the next generations. So that is a huge impactful project that we have worked on. Post that, I currently work in MRI machines. I moved from CT scanners to MRI scanners. So I work in Philips as part of the research and development teams. I work on development of pulse sequences again for various applications. Right now, my focus is more on even neuro in the brains I'm working on these days. So that is more my focus on. So this is about my background. So let us come to where you guys are today. Okay, I'm assuming most of you are students in 1, 2, 3, 4 of the engineering branch. So let us go through, how do we define, or what do you guys want to do? Okay, so obviously after your +2, we've joined the chemical engineering. Some of you must have joined it by as an option. You know, I want to pursue chemical engineering. For some people, it must have been just that, okay, this is the best I can get from what I want. Either way, now that we are here, so let us look at what, I don't know how many of you Googled what is the definition of chemical engineering. Today I was thinking, who is a chemical engineer? Actually, I don't even remember what is the definition. So just a refresher on that. It's a branch of engineering that uses principles of chemistry, physics, maths, biology, and economics. So interesting, right? All the different subjects that are involved in chemical engineering. It's not just chemistry, or it's just not one particular branch, but that's the beauty of chemical engineering, where you're exposed to all these different fundamental basic subjects. And we use these to efficiently drive, design, transport, and transform different products. Like, you know, we make sugar, smallest industry, paper, from waste, we make paper. Everywhere you touch, there is a chemical engineering process that is involved. So every particle, everything that we do, chemical engineering contributes to it. So that's a very, very profound way that we impact the entire world around it, be it the drugs, be it the, you know, the water, for example, the drinking water that we have, that comes from our RHO processed water, okay, osmosis process. So all these are uh, byproducts of chemical engineers, what we do. So we all should be very proud, so to be a part of the chemical engineering factory. Faculty. Sorry, I meant to say the family. So where are we involved? We are involved in many aspects of the plant design. Today, these are the tasks that we look as part of the chemical engineering jobs. We are involved in the plant design, operation, the safeties that we have to do to make sure, especially in the petroleum industries, petrochemical industries. The process design, of course, the PDC that we learn, how do we analyze that? Modeling, of course, that is given bread and butter for us, and a lot of software that comes to do this modeling these days. No, so it's a lot of thing that is software driven modeling that we try to do now, and systems controls are also all software driven these days. In addition to that, the CRE, the chemical reaction engineering that we learn, the nuclear, how can we contribute for the nuclear power plants, and also in the biological engineering, you name it. All of these are part of the chemical engineering spectrum. So usually I think what I want to at least talk to you people as, there are two perspectives that we have, right? So either you pursue, you finish your graduation, you want to go into the industry, or you want to pursue a higher education. Ideally, if it was an audience poll right now, I would have asked how many of you would have opted for higher education and how many of you would have gone for an industry. Assuming that I have a 50-50 break, I'll go with that. So why would you want to pursue a higher education, or why would you want to go to an industry? Both are equally good. There's nothing bad in either one of them. It's just what you want to do, how you want to learn more. Clearly, industry gives you, you know, the impact. What do you mean by impact? I cannot sit on a project for 6 months. They will fire you right away. Okay, that is a given. So the industry works in such a way that it has to be delivered to the customer, and you have to make money out of it. So industry runs, it's a cycle which is evolved to deliver very fast to the customer and make money out of it, so that you can invest again in another product. The industry cycle, whole thing teaches you to be quick. you cannot sit idle. You have no time to think, and you cannot do an elaborate, greatest work that can be possibly done, but it is not going to go to the market, and I'm not going to generate revenue out of it. Industry typically does not support that. There is very few sections of the industry which will help you do that. But what industry teaches you is to keep on your toes, and the amount of knowledge you gain, not just from your textbooks, that's all you learn during the engineering, but when you get into the industry, you know practically what is that cycle. How do you survive? How do companies survive? How do we create jobs? All that perspective you get when you join an industry. So that is the good part. And of course, you make the money quickly. That is a good part also. Now coming back to higher education, why would one has to pursue a higher education? Why can't I just go for an industry? So there are two things I would say over there. Higher education, what it teaches you is exposure. Exposure, all in your engineering, you guys are still very young, lesser 18 to 22, 23, very small. You have very high hormones and your mindset is such that I know a lot. And that's common for anybody of that age, that population. And you know that you are very smart at that age. You can understand things very well. But what we lack when we are at that age is that perspective, of how things work, how they evolve, what is the repercussion of doing this, how should I do that? All those sort of grinding factors which make you think as a better person, uh, that comes from your higher education. What also higher education teaches you, especially like your master's or your PhD, what they teach you is, okay, typically what you do in your master's or your PhD, you say, okay, I'm going to solve problem A. And what they tell you is, how do I solve problem A? I'm going to take, okay, this is my hypothesis. My hypothesis is that can do, I can solve this problem using steps A, B, C. So not necessarily that you will be able to solve the problem. It can be a failure. A failure PhD is also accepted as a PhD. It doesn't always mean that you have to pass. But what it is teaching you is, if I fail, what is my alternative step? How do I move from step A to step B? If this doesn't work, then what do I do? That whole gambit of going from 1A to 1B, at the end I need this solution. That is what I need. But how do I get to this solution if something I'm roadblocked or I'm blocked somewhere? That whole navigation path, that perseverance and thinking that way, that is what your higher education does to you. In your undergrad, I think you have too much subjects, you have too much curriculum to do. You don't get that chance of exploring things. But in your master's and your PhD, you have lesser coursework to do, and you focus more on your projects, which teach you how to navigate and how to solve problems. That is what higher education helps. And it broadens your horizons because you learn more, you study more. Okay, that is more about the industry versus higher education. Uh, any questions, or I'll just pause for a minute and just check Shiva or anybody has any questions or anything that I can answer, or I can continue. I can continue.
Yeah, Yuma, you continue.
Okay.
Yeah.
Uh, so now, typically, what are the industry places where we are recruited today are in the nuclear power plants, in the pharma. I think a lot of pharma companies are in and around Vizag as well. So it's a good ground where people can be recruited very fast. In addition to that, petroleum industry is a huge industry where there's a lot of prospects for chemical engineers, product development, process development scientists, where you make these whole processes as make them software. Like you don't need reduce the human dependencies in these. And the other one is called the biotechnology. We already have biochemical engineering in our curriculums these days. Biotechnology is also an evolving field. I think we also know a lot of them that are there in and around Vizag, Hyderabad especially, where you have a lot of prospects for the chemical engineers, where you get good job opportunities. You can be joining as a process engineer there or as a product engineer there. How are we going to be placed? What are your roles and responsibilities? There are lots of them in these fields. What we don't have so much of exposure today is what I want to show here. One such field is the nanotechnology. So what is this nanotechnology? I'm not going to go into too many details. I just give you a flavor of it, okay? So all these particles, for example, let us take this particular example, just to give an idea. All of you know what a heart attack is, right? This is your heart. This one keeps pumping blood to your entire. I talk a lot about heart because that's my area of expertise, but it's also very important for each one of us. So your heart keeps. What does your heart do? It's as small as your fist, okay, and it sits on the left side of your heart. Boom, 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 boom. From the time you are born, the first organ that is formed in the human body as a fetus in your mother's womb is heart. First is heart is formed. Then the rest of the organs are evolved. So from then on, the poor heart keeps pumping, pumping, pumping. And the day the heart decides I'm not going to pump, we are all done. Our chapter is closed. So the heart is a crucial, part of the human body. So sometimes we've heard of these heart attacks in patients, right? So what happens in heart attack? So this whole, what you see, this whole, can you guys see what I'm trying to show here? Is it highlighting?
Yeah, yeah.
Okay, okay, thank you. So this part of the heart is called the pump. So it keeps going tuck, 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 tuck. And so suddenly sometimes what happens is due to blood not going properly, some parts of the heart, like you see this black guy here, ideally it should be red with blood cells like this, but because of blood not flowing here, it becomes black. And this one has to be repaired, otherwise your heart you get that chest pain and you have to get treated for it, otherwise tissue gets dead and there's no more functionality of your heart working properly. That's when you get tired very quickly or you cannot do any strenuous exercises. So what they try to do is they try to regenerate this tissue. What do you mean by regenerate? See, when you get a scar, when you fall down, right, your tissue comes back. Yeah, any scars, if you remember from your childhood, all of them, the tissue grows back by itself, right? There's nothing you have to do. So that is the beauty of the tissue. So what they try to do in this nanotechnology is they take these small particles, very, very small particles, and these they grow it on some layers of tissue culture. Let us keep it that way. Some layers of papers, for example, assume it to be some papers. They grow the small nanoparticles in there and then they bring it and they stitch it back on this heart. Now then the heart thinks, okay, I got some muscles too, I got some material. So now I have to repair myself. And it will start growing back itself in a very beautiful manner. And this will start making the heart look red again. Okay, so this whole black heart, it becomes a red heart again. So this is something as part of, I think, okay, this is part of the tissue engineering that we call. So how can we contribute as chemical engineers in tissue engineering? If you look at it, we know the chemical reactions that they occur when two materials, when you mix two things, potassium, whatever we do in our labs, they are more inorganic material. So now what we do is we come and apply it to human body. How can we do all this in the human body? How can we grow the heart there? How can we go back? How can we make this dead muscle come back? So that is all part of the tissue engineering. How do we use this small, so how do you grow this? What are the chemical, what is the fluid that we can use? What are the type of technology we can use? What is the material we can use? So the materials, that is what we do in chemical engineering, right? How do we develop this material, this plastic, that resin, that plastic? How do we combine these two to make up with some other new material? So right now, I don't know if you guys have watched it, but Ford right now, they use McDonald's. Earlier Ford, the front lights where you have the headlights, right? Those get heated up very quickly. They're made of one type of a plastic resin. So that we used to get it from some mica also used to be that we used to use plastic and mica and make that emulsion, and out of it we used to derive that. Now they have innovated and now they use this coffee chef, the one that they don't use. So now Ford is taking all this coffee chef that McDonald's doesn't use anymore. They wash it and that gets all going into the dumps. So now all that layer, that material is taken by Ford factories where they use that and plastic and they mix it together and they form these headlights. Now that's proven to be a much lighter part and all. So I will not digress, but the whole point I'm trying to tell that is that's part of the chemical engineering DNA, right? That's what we do. Mix and match and figure out what is the best, how can we make it better. That's exactly what they try to do in the chemical engineering, I mean, in the biomedical engineering as well. But you have a little bit more complex biology also part that is involved. So you have to understand, we have to adapt our chemical engineering skills into the biology environment. That's what we need to do as chemical engineers. That's also a brilliant area for all of us to explore. In India, we are getting there. We are still probably not there completely yet, but that is definitely a path where I think from an industry point of view, we will also grow a lot. So that is another application for chemical engineers. In addition to that, what do we use this in nanotechnology? You know, all this chemotherapy for cancer patients, we say, right? Targeted cells, we give radiation, we give targeted cells. So what are all these targeted drug deliveries? They're all part of chemical engineers. We can contribute for those. How can we contribute? We learn CSTRs, we learn PFRs, all these we learn. What do we learn there? We learn how to solve the equations, how to deliver to the particular equipment, how to deliver to particular to the process. Again, we engineers, again, chemical engineers, we engineer our chemical engineering background knowledge into the biomedical engineering. So how do I make sure that there is a drug or there is a chemical A which is causing the cancer? I want to use chemical B to go only to chemical A. It should not go to chemical C or chemical D. That is called target drug delivery. That's what I have highlighted here. Okay, all these are again impact of the chemical engineering products. Okay, so I'll keep moving, otherwise I will go slower, I think. In addition to that, we are also giving as drug delivery. If you look at there are a lot of asthmatic patients that we know, people who cannot breathe. This is again another example. I cannot breathe well. So what you typically we used to do, okay, cough. If we get this chronic cough, no, when we do so much. Now the COVID, for example, the symptoms of COVID are what? Chronically, you're coughing, fatigue, all this. So how do we used to treat the cough in older days? We used to take the tonic. Boom, tonic, take doses of tonic today, morning, afternoon, night, morning, afternoon, night. It takes what the medicine has evolved and have told us that it's very ineffective. It's not so quick. So now what they do, they put a mask on patients, which you must have seen right now. So those masks, they fragment this medicine, they fragment it into small, tiny particles. They are breathed in through our noses and they go into our lungs, directly into the lungs and into the smallest part of the lungs, and they're far more effective than our older tonics. So if the older tonics takes 7 days to recover the patient, these direct delivery drugs, which are going directly into your lungs or the specified area, they give you a remedy in 2 days. 2 days you feel much better. That chronic cough goes down. So all these are again where areas where drug delivery in biomedical engineering, in our biology engineering, but chemical engineers have a very good what do you call pathway to get there. Okay, these are some flavors. So next is where my passion is more into. I work on the biomedical engineering that you see here. That's a CT scanner where I don't know how many of you have seen it. I hope you don't have to see, you or your family members don't have to see. But in case of a need, so this is how it looks like. It takes pictures of what is inside. I'll just show you what it is in the next few slides. So this is the assemblies that we try to do. This is how the machine looks inside. So I don't do the whole machine. Obviously, there are a lot of teams that are involved: firmware, electrical, hardware, mechanical, you name it, they're all there. But to bring it all together and make it work is what my job is. So here, all of us are there, happy, hunky-dory, crossing a street. Boom, suddenly there's an accident, and then you have to go to the hospital. What happens? Your first doctor looks at it and says, hey, I think I see some problem in your head. But what is the problem? I can't tell. So he tries to, this is just a goofy guy trying to see, can I see what is happening inside your ear? Inside the body, you cannot see, right? That's humanly impossible today. The only way you can see is just meditate and see inside. But otherwise, there's nothing that gives you a picture of what is inside your human body. So that's where I work on. It's called take a picture of what is inside you. It's more like a scanner. Not this is just a funny CAT scan. They're making fun of it. But what we are trying to do is exactly the same. You put a patient into the CT scanner. You use computers and you want to see what is inside the patient. Are we okay on time? 10. I should be wrapping up in another 10 minutes. Okay. So there are
Okay,
different.
okay.
There are other different ways to take the pictures. The first, I think most of you know what's an X-ray. You put X-rays and you take what is inside. This is your chest. If you are into a fight or you have fallen off a bike, usually one of them is broken, and we see that. This is called simple X-ray. You give some X-rays and you take a picture of the patient. Next is a CT scanner. This is a little bit more complicated. You put the patient in there. You have more than one X-ray. There's a rotating gantry and all that go on in here, and you take an image out of it. Sorry. Then there's also something called ultrasound. The intent is the same again, to see what is inside the patient. And finally, the MRI scanner, where we use something called magnetic resonance imaging, where human body has a lot of water molecules. We use those molecules and try to take pictures of what is inside. So this CT and MRI is where I have mostly worked on. Ultrasound works on the basics physics of sound. So you give sound, you pick sound. So based on how far the sound is from you, you'll be able to tell where is this object. So like this is a classic example is the what do you call the ambulance, the siren guy, right? You can tell, is it close to me or is it far away from me because of the sound waves. So ultrasound works on those. X-ray and CT work on the X-ray physics. MRI works on the magnetic, which is there, I mean, the protons which are there on the human body. We use the same ones to take pictures. So this is just to give you, I don't know how many of you have seen this picture, but these are the pictures of our brains, huh? Some other patient, not of us. So if you put a patient in the brain, a patient in the brain scan of the patient, so this is what we will look like. These are all the different parts. This is your eyes. Okay, this is your nose. And this is your ear part and all. So as you're going above and above and above, so above means I'm saying this sections of the head. So this is how, this is your gray matter and your white matter in your brain. This decides how smart you are. Gray matter is more or white matter is more. All this is defined in here. So what do I do in all this? I don't do everything, obviously. So my team, which I work on, we work on in two parts. One is we try to do for the heart and one is for the brain. How can we make the images? This technology has been there for a very long time. Okay, I will, you know what, I'll come back to these images again. I'll just go back to the next slide. So this is about history of X-rays. Röntgen, he's discovered them in 1895. What he has done, he has put his first victim is his wife. So he said, okay, honey, I want to see how your fingers are. And then he puts his fingers on the X-ray screen and he takes a picture. What we see here is the wedding ring of his wife. So these are the bones that are there in the patient, or the, sorry, not his patient, not the patient, but his wife. So Mrs. Ranjan was the first X-ray exposed person. So this, after this, we see now we typically use it. You can see here clearly. I hope you appreciate a broken anatomy here, right? So these are all used in medical imaging since 1896. So this is for CT. Similarly for MR. So the first physics fundamentals comes typically for all these technologies, right? So the first you have to do a lot. It's a very, what do you call it? It's a very phased way of looking at the research. So first research is done much earlier, 1920s, 1930s. They had all the physics behind it, but what was lacking is the computers. So they could never process. So to do one brain scan in 1970, if I'm not wrong, they would take at least an hour to do one brain scan, not the entire brain, just small section of the brain. Now, today, you finish a brain scan in, if you go to the high-end CT scanner, 1 second, like this. Heart is one of the toughest guy to scan. That will also you finish it off like this. Now your CT scan is super fast. You can get all these images. All this has happened because of the combination of how physics is there, chemistry is there, and then you bring computers. So the whole point is, as chemical engineers, you don't think that this is all I can do or this is all I should do. That is just a what do you call that? All you're doing in this 4 years of chemical engineering is learning how to learn and how to use things. It doesn't have to be in the particular exam or in the particular lab lesson or in that particular job, but understand how can I use what I have learned in other parts. Okay, that's what I want to share here. So then the MR scanners were evolved, and finally, see, 1938 to 1977, the huge gap. Now, finally, we had a scanner where we could take pictures of patients. So these are all the different types of pictures that we have. All of are of brain. I'll just show pictures here. I'll not spend too much time for you. But what I want to show is all these you need in the hospitals today. This is a beautiful image. This is how all the wiring is there inside your brain, huh? All your blood vessels. Your brain gets all the circulation from your heart. And this is again your neck. This is your carotids, your necks. This is how all the blood is flowing. Okay. And these are all the brain images again. Again, I will not bore you guys. So some of these are also used for detection of cancer, how they are, if there is any therapy we have to do to the patient, everything all to help patients. Okay, that's what we do. So this is the MRI system, how we try to do. Okay, so then so this is all about what I work on or how I have shifted from chemical engineering. So obviously when I was doing my chemical engineering, I was working in masters also, I was doing core chemical engineering subjects. But that's where I took a small diversion. I took some courses in anatomy. I took some courses in physiology. What is anatomy? Human anatomy. Where is my brain? Where is my other parts? Where is my chest? All these parts are there in the anatomy courses. Then I took it some in the physiology. How does the blood circulate? If I get a wound, how does it get healed? How is so little bit of biology is what I have learned. And then I have used, frankly, believe it or not, the first principles that I've used for my modeling in my first project were core PFR. So I've used the same equations and tried to solve a human physiology conditions where what we were trying to do is give some contrast to the patient here and see how much time it takes for it to come to the heart. So I'll just use a chemical CSTR, how we design them. So same principles I've used, solve those equations in MATLAB and try to come up with a model. That was my first project. This is, again, all you do is learn your principles, learn how to use them. In addition to that, there are some very, very, very important things that I see today because I'm much older than what you guys are. And I see that a lot when I talk to these students and uh, juniors who work with me. One, you should, what does everybody want? Everybody has problems. You have problem, I have problem, my son also has problems, everybody has problems. So nobody wants to hear your problems. Everybody wants to see how can you solve a problem. It doesn't have to be the best way and it doesn't have to succeed, it doesn't have to succeed each time. But what they want to look at is, what you should learn to look at is, how do I solve? It comes from, your approach. The reason why I'm saying this to you is, it should start from today. You should start understanding that how do I solve problems? How can I think of solving? It can be, it should be an attitude. Okay. How they want to look at, how do you solve problems? How can you analyze the issue in order to solve the problems? And how do you interpret it? It's not good enough. I'm a genius in my mind, but I cannot tell about it to anybody. Nobody wants you. Nobody wants to work with you. Nobody enjoys being with you. And I have personally seen people who are asked to leave their jobs because they're super smart. Huh? If you look at their IQ skills, they're somewhere there. Average IQ is here, they are there. But nobody wants to work with them. So these are all some soft skills that we all have to learn. And second most important thing, I'm reiterating again, please learn computer coding. Please learn. Learn either it can be C++, C Sharp, or MATLAB, or Python. I mean, there are hazar things today, but what you should, don't learn it like in a textbook. Okay, don't, that is not going to help you. Don't learn it how we write in the lab, right? Add to numbers, divide to numbers. That is going to do only for your lab work. Okay, you should have an end-to-end understanding of how to use it. There are so many projects online. There are so many websites that help you. They give you challenges, and this doesn't have to be part of your curriculum. This is for your own benefit. You have to learn software. Otherwise, you will not survive in the industry today. Not just industry, in education also. There is no place today, frankly, where I will do only theoretical subjects. That doesn't work. You have to work on applications. You have to work on software knowledge. These two are a must in addition to your soft speaking skills. And also you have to look at, the others are all, I think, very self-explanatory, but how do you give detail? So if I have a team of 10 people that I work with, out of the 10, I definitely know there are 2 people I can always rely on. Why? Why? I know if I give them the task that it will be done, because the attention to the detail and end to end. My professor has asked me to submit the book. It doesn't end there. What did he ask from end to end? Have I finished from A to B? And this is what is looking for. That whole circle you have to close. Obviously some people are wired much smarter than others. They have the creativity better, they have the ability to think better. That is okay, but hard work also brings you there. Okay, so if some people are inherently there, some of us are here, and but we can still work hard and get ourselves maybe not here but still above where we are. Communication and presentation, these are all soft skills. I'm pretty sure that you taught a lot about this in your offices, I mean sorry, in your curriculum. But communicate clearly. You can talk clearly only when you know clearly. Okay, that is if you don't know, you start blabbering after stage 2. You're like, I don't know. And I have myself done that during my viva. If I'm not clear in what I answer, I will ask another redundant I will tell another redundant answer. Then obviously the professor gets to know about it. He will ask another question which I will again give another redundant. So at the end, you know you're making a fool out of yourself. So unless you know it thoroughly, you can never answer it properly. So that clarity comes when you have that clarity in mind. Also work in groups. You have to be a good group worker and you have to learn how to work with people. Otherwise, there is no point. There's one very recent interview with, there's a recent clipping that is going around. Saurabh Ganguly talks about how he has to manage two different types of people. One is some meticulous guy like Rahul Dravid, and another guy is this pompous, what is his name? I forget his name. Harbhajan Singh, not Harbhajan Singh. Oh, I'm forgetting out his name. Okay, anyway. So he tries to tell how he has to balance out both of these guys while playing cricket. So that comes where how you mingle with people in your team. So eventually, once you get through that, you get into the leadership roles and project management, but that's a later stage. But initially, these are the important things that you have to work on. Last two slides I have, and then we'll be done. One is innovation. Uh, I think innovation doesn't have to be a leap, okay, from here to there. No, innovation is always incremental also. Small things. What are we as engineers? What do we do? How do we make life better? If I'm having a problem, we should not live in that problem. How do I solve this problem? Am I making my life incrementally better? That can happen. It can happen in your day-to-day chores at home. Your mother probably still uses the same where she's trying to fry the pan, but her hands get burned. How can I make it better? These are all smaller things, but that gives you the ability to think, how do I solve the problem? Solving the problem skills is what is teaching you. It can be incremental again, but always try to focus on innovation. And innovation doesn't mean 10,000 things come together, right? Jugads we talk about, right? That they're all innovations. Have it as a practice. How do I solve this? Okay, today I cannot do. Look at your. Yesterday I was surprised. I purchased a new hanger for drying clothes. I saw the older ones used to be this big bulky ones. You have to pull them all of them down, put all the clothes outside, then pull it again, like do Herculean task, put it all up again. Now you have the single layered ones where you pull one down, put your clothes, pull it up, and then put the other one down. And they're also in a structured manner. They're not all of the same level. So it's all very creative, right? That's a very pretty neat idea. For me, it solved my problem. I don't have to pull it like like I'm lugging through some big wire or something. So it's nice. It's nice. So small innovations, but perfect and good money. I'm sure that guy is making. So that brings you to the entrepreneurship. How can you be a good entrepreneur guy? By having a knack. You have to have that vision. You have to have that eye for details. Okay. These are some things Dr. Shivnaresh was pointing out that you guys have these in your areas, in your office. I mean, in your curriculum. They're not part of your curriculum, but there is some activities going on for you guys to work on these. Think about again, read papers, read these technology papers that you get, the biology, I mean, the whatever journals that you get. See how are they solving the approaches. Look at the approach, and you can solve it in your own labs. It can be smaller things, but that's still fine. The way that we do some equipment, the way we do it today is probably not the most optimal way. Nothing is the best. Okay, always you can make it better. But that is also a part of your innovation. Okay. And last but not the least, this is my last slide. Present yourself in a professional manner wherever you go. Don't do it for others. Okay, that is something I think I also have learned it once I've gotten out of where we are. See, it's also what we see is what we learn, right? So we grow once we get out of that whole conditioning that we are given. We go out. Don't work for somebody else. It's what we are doing is for us. What the tasks we do is for making our lives better. And that ethics, that's something that we have to learn, that we have to imbibe. Nobody has to tell us. And respect people. Don't put down people. You never know who gets good. Okay, sometimes it's that particular field that that person is not good at. But so these are all, this is probably like gyan sorry, but this is all to just to make you sure that respect people, don't pull down people or anything. And one last point I want to emphasize is, I don't know how many girls are there in here, but yeah, I think even the guys should know this, not just the girls. But I see a lot of, also I've heard, the gender proportion is very very low. You see very few girls to very few boys ratio, you know. One example I'll give, and this is the last one. There was this one guy, I think some, I don't know from where, but he has very good crop yield. Okay, he has the best seeds that he has. So then he asked, apparently then he would distribute this best seeds to everybody around his farms. And then people would ask him, why would you give away your best ones? You know, you that if you have best ones, you will be the one who will make the money. Now everybody around you will have good, how can you make more money? So that guy said a very simple answer. He said, see, if there are bad seeds within them, through this pollination, they will come into my crop as well, right? So I'd rather give them also good, so that they are happy as well as I am happy. So the only way we all can grow together as a society, or as as individuals or as a society, is by making everybody around us will have a better life. So for that, it means giving equal opportunities, improving. How do we make sure that your girl colleagues or your juniors or your seniors, whoever they are, how can we help them having a good opportunity at workplace? Especially in this. There are areas where they typically do not like, in the processes, for example, where there is a furnace or any of those, they would not want the women to work there. That is probably because of the conditioning we are, and women also, girls also thinking that they are less stronger, which is not true. I think all of us are equally capable, equally there. It's only our perception. Don't let your parents or bog you down. Oh, no, 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 you are not somebody, you can do that. That is all a mindset. Okay, you are what you are. You are what you think you are. Okay, so please, guys, help out girls where you know that this sort of discrimination is happening, especially if you see it at a workplace or in your labs or in your universities. Don't bring it down. Don't make it that you cannot do that. That's okay. That's not the point. And girls, you also have to think about yourself. I can do this. We should be able to do this. There's nothing rocket science in that, right? So you're equally strong. We're equally fit. We all can also do that. That is the last note, and that is my favorite. That is somebody who I look up to. I don't know how many of you recognize that. That is Madame Curie. She has won two uh, Nobel Prizes, one in physics and one in chemistry. So that is just to show that everybody is equal. Everybody is equally smart, equally good. It's all how we work on ourselves and how we make ourselves a better people. All right, with all that, I will say thank you very much, and thank you very, very much for giving me this opportunity. Sorry if I've overshoot. Now I can take questions.
Thank you, Uma. Can you see the questions in chat box, or can I read it out?
I can let me check. Okay, just give me 1 minute. I want to see how to do that. Chat.
You
Yes.
stop the sharing and can
Yeah, I
take it
can
out.
stop sharing, and then okay. Now let me see the chat window.
You have two questions right
Okay.
now. How can
Okay.
we directly enter pharma after BTech? Is it better than petroleum and energy department to pursue as a career?
Oh,
How
hold
do
on.
we choose these MTech specializations? Either
Okay.
pharma, petroleum, energy.
Okay. 1 second. I'm just pulling it to my other screen. Give me 1 second.
Yeah.
How can we directly enter pharma after BTech? It is better than petroleum. Yeah, I think right now pharma has a lot of money. Right now, definitely. Petroleum, if you look frankly at the industry point of view right now, medically, so there are industries, right, which they predict how these industries are going to do in the next 10 years, 20 years. So based on that, these careers come up, right? So definitely medical, anything related to medical has a lot of money and a lot of research and has a lot of value added in it. So pharma is definitely one of them. How do you get into pharma? I think if I'm not mistaken, right now, companies itself, they're okay with recruiting directly after your BTech, right? Shivnaresh, you can add probably more into that because pharma is not something I'm very much involved in.
Yeah, yeah, you are right in saying so. After BTech Chemical Engineering, we directly enter into pharma. But to choose as a master's as a career, I think we have to shift to either bioprocess or biochemical. We can't take M-Pharmacy. For M-Pharmacy, we have the B-Pharmacy degree. Uh,
Okay,
so,
okay,
uh, so for as a chemical engineers, we can enter into bio sectors, not directly into a pharma sector. So
okay.
you have the other question also at the down.
Huh.
I think she
Uh,
got more.
Good, Harini. I'm happy. I hope you talk to your other colleagues, I mean, other friends, and it's about how we all get better, right? That's all we should look at. Okay. I'll answer your question. You told after your master's you studied human anatomy. You're a chemical engineering student. I'm interested in drug delivery. Okay. So there are two ways. Like, see now in India, how we have is we have only our university, right? We have just our university. We do not have the medical industry, medical schools together. But what you also can do, it is out of interest. If you want to learn human anatomy, I'm sure there are courses where, I don't know, Geetam or Gayatri or any of these places, you can go and you can enroll. They will not give you a degree or anything, but you can go and you can audit classes, they call it. So where you go, you learn the subject and you come out of it. So there is no degree that has been given for you, but you get that auditing course certification or something they will give you. Okay, this is my understanding. So with that sort of courses, you can go to any of these places and ask them, can I just audit this particular course? Where your intent is to learn in that course, but they will have some background that you have to learn for that. Do you have to do probably some anatomy classes before that, or I don't know exactly, but you have to have some background and go for any of these. This will give you an auditing thing. That's how you learn them. Right now, actually, frankly, if you look, there is internet also, you get a lot of it, but a systematic coursework and all online courses are also you can check somewhere where you can apply for I think MIT gives that, Stanford gives that. There are so many of their web courses that are there online. You can enroll in any of their courses. Most of them are free. And at the end of it's a 6-week course or an 8-week course based on the course structure. You can enroll into that. And then you can take whichever subject you want. At the end, they will have an exam and they give you a certificate. That's one way of doing it. And to answer your question about drug delivery and how to get interest, that is a little bit once you finish your undergrad. I think today we don't have so much of drug delivery research in India as such. It is more in other countries. Naresh, do you know more about it? How do we have for the drug delivery in India?
Yeah. The institutes like IIT Madras and Institute of Science Bangalore,
Hmm.
there are some interdisciplinary courses in the drug deliveries. So most
Okay,
of the
okay,
computational things, as well as some biochemistry, biophysics are going on. I think they
fantastic.
can opt for in their doctorates, not in masters or BTech.
But they can take
Uh,
coursework, right? I mean, part
yeah,
of
yeah,
the.
yeah. So,
Uh,
so, so in our curriculum, in all the Indian education system, now we have a MOOCs course where they
okay,
can audit a course and they can take the credits back.
perfect,
I think
perfect,
they can opt for that.
perfect, perfect. So that answers your question, I hope.
So I
Fourth
have
year
one more question. Student.
fourth year student, and I would like to know what is in your mind when you are going to graduate higher studies or working in industry. What would you suggest to a girl
Girl
going to get
student going to
graduated?
get graduated.
So yeah, actually I'm not very smart. Your professor, all these guys are much smarter guys. So I didn't know what to do. I knew sure I was not going to get selected in the MTech. I was not going to pass the gate. I knew that. Okay. So then I thought, what is the easier way out of this? Okay. So I was joking, but frankly, so what at that point, what is I didn't think of. I knew I wanted to study more. So it was just an answer of where I want to study. Do I want to study in India or do I want to study abroad? It came as an opportunity for me because I was getting good scholarship there back at that point of time, and it was all funded. That is why I've decided to pursue my master's abroad. Now, is this your question was more? What would you suggest? So what I have also learned is after my master's, I have worked for one more year. Okay, And what I have learned during that 1 year of working, I have never learned in those 2.5 years of masters. So it's a different perspective. But then again, what I have done during working, I've been able to utilize what all I have learned during my undergrad and masters in here as well. So it's a two-way trick. So if you are sure that I want to do a master's, go for it. But if you say, I don't know, and I don't know how to feel about it, then just work for 1 year. That gives you a clarity of thought. Okay, that gives you perspective of how industry works. That gives you learning curve, and from then you can pursue your masters if your still interest holds good there. I hope I have answered your question. And there's nothing to be right now. It's a very much it's a world is flat. It's no more a circular. So you don't have to be worried about going abroad and all this. It is just if you're able to travel from one place to another place, you're capable enough to go to the any other country as well. So there is nothing hindering from that perspective. Uh, let's
Uh,
just go.
that she will ask, you can ask the next question. Uh, so regarding softwares,
Mhm.
we should know either Python or C++, but it's very different from our syllabus. And in that system, new technology was invented every day. We should go to IT software or our chemical software like Aspen HiSys.
Yes, okay. Very good question. Very good. So your chemical softwares are our core softwares. Okay, they are what we work on in an industry-based thing. Now, as long as you know that this is the process one that I'm going to go, it's good. Perfect. Learn Aspen, learn whichever softwares that are core oriented to us. But what I'm trying to tell is that's exactly my point. Your curriculum will never teach you that C, C++. You go to a computer science. I am sure you all of you have your computer science friends, right? They know how to code. So once they get a job, they know how to work on these codes, right? That's what they'll be contributing as software engineers, right? That's what they'll be trying to do. So all I'm telling you is have that learning skill. How do I use tomorrow? If I were to become see, all of us have to use software. Okay, today you will use, somebody has written this blocks for your Aspen. What is an Aspen? Okay, you want to model your CSTR. You take one block and you put it there, right? Somebody has written a code for this to be modeled like this. So either you can be the front end consumer, which is what we are when we use the Aspen, or you can be the back end guy who has written this code for this Aspen to work this way. You can be either one. All I'm saying is learn that back end also. Don't become, so say tomorrow you have to change your industry for some reason, I don't know. You want to change your industry, like I had to change to biomedical from chemical engineering, and I didn't know how to code. Then I had to sit and try understand MATLAB, write MATLAB. So avoid that in your early stages. Now is a good time for you to invest like that. There are so many of them. You can learn from software company. I think they do coaching centers and all, right? Where they teach you, they give you a diploma in 6 months or 8 months. You don't have to go to them also, I'm saying. You just have to understand how, there are, I should tell you, I can't recollect of them, but there are so many websites now which give you projects. Start on that Python projects. Okay, Google and you'll find so many websites. They tell you this is what you should be doing on the Python projects. Okay, this is what I want to extract from these. So all these are all online now. To answer your question again, if you want to stick only to the front end user, I want to only core chemical engineering one, I will learn Aspen, that is good enough. But if I want to learn my in-depth knowledge and have a broader perspective, I have to learn either C++. C sharp, C++ are still the most used ones. So the next
That
one
I'll
is for
answer.
you, I think.
Yeah, yeah.
Yeah.
So there is one question. What should be the opportunities for one who is interested in MBA after chemical engineering?
Opportunities for MBS, huh? Okay. Yeah, I am not so much into that field, frankly, but I know a couple of friends who have done that. They have not from my engineering college, but my couple of other friends. So one guy, he has done in Andhra University chemical engineering, and from there he has done in Ahmedabad right now. So he was clear. So he has a company right now where they do we do all paintings, coatings, right? How he has used his chemical engineering, I want to tell you there. So we use our all this for whitewashing walls and all. We use the paints, right? We have that, so we know the technology. So he uses that chemical technology to paint the heart valves. You have your valves in your heart which keep moving. So he uses this understanding, and in the biology, of course, of the heart, he uses them to paint the heart valves. That's his company that is focused on. So his MBA he's gotten from Ahmedabad. Opportunities wise, it's a very good combination, obviously, because you know the chemical engineering structure, and then as an MBA, your expectation is different. You don't do the processes and all. I hope you differentiate that, right? As an engineer versus an MBA graduate, your job responsibilities are very different. The way you're hired are very different. An MBA guy is usually done for running the business. Whereas if you're an engineer, you make the business go. So you're a more techie guy. MBA guy is more the number crunching guy. How do I keep the business sustained? How can I keep this company going alive? How do I get more marketing based on where you are, or in the HR side? That is the difference, fundamental ones. So job prospects, definitely there are a lot of them. A lot of people are interested in hiring this combination still, engineering and MBA. So that's a good option as well. But try to get it from good schools, I would say.
There is a question from Professor Subbarao. I think he was the external for our MO, mechanical operations, when we are studying in Rajam. And now he's working as a professor in our department. And
Okay.
he's asking you to comment on the job market salaries of biomedical engineering now.
Okay. Biomedical engineers, I don't know about the entire field, but I can tell for my field right now, which is more in the medical imaging domain. In India right now, in medical imaging, there are 5 big companies. We are still focused a lot more on the software part of it, but I'll tell you the companies first. GE, Philips, Toshiba, then GE, Philips, Toshiba. What am I missing? GE, Philips, Siemens, Toshiba, and then what is the Korean company? South Korean company. I'm blanking out on the name. Okay, these are the 5 big competitors.
Huawei or it's some Huawei?
No. Okay, it will come back to me.
Samsung. Samsung?
Samsung, correct. So
Samsung.
these are the
Samsung
5
team.
big guys that are manufacturing this huge CT. All these are called medical imaging equipment. CT, MRI, and ultrasound. All these equipments. So if you are a first level, just graduated, obviously it's very hard for you to go without a. If you're, for example, if I go with a chemical engineering degree to a biomedical office, they will not hire me, right? What will they? What will they get out of me? Right? So that is not a right transition to make. For example, if I say I'm a biomedical professor, I want to teach chemical engineering to you, you'll first ask, what do you know in chemical engineering to teach me? So that is not the right way to move. But if you were to move to as a software engineer, like for example, I can learn this background for these biomedical equipment, then your starting salary is about, I think they give about 6 lakh maybe, but their intent is to more know that you have to know this coding skills, software skills. Otherwise, they will not hire. 6 lakh per annum. That's more on an average, I would say 6 to 8, because very good schools they get from NITs and IITs when they get around 8 or 9, I think. Yeah.
Yeah, they get around 6 to 7 actually. NITs, IITs.
IITs, no.
Yeah. So there is one question from the industry point of view. I think the role of a chemical engineer in a pharma company is PhD or process engineer. Then why they are treating as a chemist? Even in MNCs also it's the same. Can you differentiate, madam? Every chemical engineer couldn't be some public sector holder or MTech holder, but he has good knowledge about chemical engineering.
I
Okay, so
know.
one problem, one problem is that the fresh chemical engineers they are given as something like a chemist, not as a process engineer or something. But
uh,
after they gain 1 year of experience, they shifted to a process engineer or so. So
Correct.
maybe his question is somewhat on that.
I'm correct. No, I think that is tricky. That is, I mean, one way you look at it is feel bad about it. The other way you look at it is, now I can very well do what a chemist can do, right? So no, just look at it. I get your point, but also it's a need. Okay. Also, we also have to understand everything is not put in, everything is not set for everybody all the time. You have opportunities, you have struggles also. I still remember when I was first time when I went to the chemical engineering lab for my master's, they asked me, everybody was writing a code in MATLAB. I was just putting my head down because we've never done anything, right, Naresh? Like writing
Yeah.
code.
No.
And then I had to design a CSTR with ABCD, and what I needed to know so it was for a caffeine project. They wanted to have some smell, aroma. They had given me the criteria. They said, now to design the CSTR, which is going to meet this output criteria. I had absolutely zero clue. And I thought I'm going to fail. My funding is going to get screwed up. I'm totally like, I'm gone. I'm gone. And I called my father and I said, okay, I'm coming back next month after they're going to throw me out of the university. So the whole point is there. What do you do? Then I took another course for learning MATLAB. Okay. That is MATLAB 101 class. So if you look at it, I'm a chemical engineer and I'm sitting with all these undergrad first year students and learning MATLAB 101. But what has that done to me? It has taught me MATLAB. It has taught me things how to work on it. It has helped me to design my project. So it is sad, but that's okay. That's okay. Opportunities are not the same for everyone at every time. It's a learning experience. No experience. Always look at it this way, guys. Never feel that I'm doing a menial job. This is nothing. This is not whatever. You learn. You always learn from everything that you do. You always learn. Maybe you will do it as 1 year. You get an understanding of that. You will learn the processes there. You will learn what the industry needs there. You learn how the things function. This you wouldn't have known otherwise, right? So look at it that way. I get your point. I understand the frustration, but that's okay. For 1 year, you can do that and then you can move on because there is a need there. There is a dearth of people there. So that's where the money is also there. At the end, it's all moolah, right? You will not want to work for free for some company. So just do that 1 year job. You get it in your resume and then boom, you go progress. Yeah.
Yeah.
Okay. No more questions.
Yeah. Sir. Think.
Hello.
Yeah. You can give a final vote of thanks.
Yeah. Good morning, everyone. Myself, Dr. Anil, head of the department. On behalf of Department of Chemical Engineering, ANITS and ANITS IIChE student chapter, I like to thank Dr. Uma for sharing a lot of information on biomedical engineering, application of chemical engineering principles in biomedical engineering field. I hope this will enlighten students to apply their principles that were learned in chemical engineering and shifting their field into the other areas, broader areas, which is important in nowadays. I once again thank Dr. Uma for
Thank you.
spending a lot of time with us and answering so many questions. And I also thank Dr. M. Sivanaresh for organizing this lectures. And I also thank the participants who is sparing a lot of time on Sundays. Maybe 1.5 hours on Sundays.
Thank you, guys.
I think they have to spare one more Sunday for us.
You guys, when the college is open, I think you should all ask for coffee and donuts or some food when these lectures are going on.
Yeah, it's true. And the management also have some financial pressure doing all these things. Okay, thanks so much for igniting these young minds. Once again, I'll make you a personal call. We'll end the meeting.
Sure. Thank you very much, guys. Thank you.
Thank you.
Thank you, guys. Thank you.